Alright, today we're going to talk about naming double and triple bonded molecules. So you already know that a single bonded molecule ends in the word -ane. You have all the prefixes in your notes. The prefixes are meth, eth, prop, but, pent, hex, hept, oct, non, dec, right? So a 10 carbon chain all in a row is a dec-ane. There's the bell. Double bonded molecules, you name the exact same way, but you change the ending to -ene. Triple bonded molecules, you name the exact same way, but you change the ending to -ine. So we're going to run through several examples. First example has a carbon chain with 1, 2, 3, 4, 5 carbons in it. Well, you guys know that any chain with 5 carbons in it is pent. But now we've got a triple bond. So, rather than pentane, it is pent-ine. Pentine. It is almost complete. The only problem is, just calling it pentine doesn't tell us where the triple bond occurs. And we need to know that. Where the triple bond occurs matters greatly. So we can number this just like we would if it were a branch. We could call this carbon 1, this carbon 2, this carbon 3, this carbon 4, and this carbon 5, or we could number it the other way. And so we could call this carbon 1, this carbon 2, this carbon 3, 4, and 5. Now just like with our branches, we want the carbon the triple bond starts on to be the lowest number possible. So if we number from left to right, our triple bond starts on the second one, up here in red. If we number from right to left, it goes 1, 2, 3, and our triple bond starts on the third. We don't want it to be on the third, we want it to be on the second. So, our final answer for this molecule is 2-pentine. Final answer. Okay, then we'll take a look at our second one. Here we have a slightly larger molecule. It's also written in the expanded form where each hydrogen is written. This could just as easily have been written CH2 as it's written up here, CH2, and not drawn the hydrogens, so don't be confused by those. We only care about carbon. And as I look at this molecule, I see that there are 1, 2, 3, 4 carbons all in a row. 4 carbons all in a row gives us bute. And it would be butane, but because they are double bonds, it is -ene. Now I'm going to leave some space here between those two. Because remember, the other thing we have to know of is that just like with our branches, if there are 2 of the same, it is di. If there are 3 of the same, it is tri. Well, we have 2 of the same type of bond. So this is a diene. So it is butadiene. So, don't be confused or frustrated by that. These same rules for di and tri occur. If you see 2 things that are the same, whether they are bonds or branches, you have to remember to put the di in. The di comes before the double bond, just like the di would come before if they were 2 methyl groups. It would be a dimethyl something. Okay, then the last thing we need to do is number this to see which direction we want to go from. It's actually a symmetrical molecule, so it won't much matter, but we'll call this 1, this 2, this 3, and this 4. Or we'll number it the other way. I'm going to use yellow to call it 1, 2, 3, 4. So our carbon either starts on, our double bonds either start on 1, 2, and 3, or it starts on 1, 2, and 3. So it either starts on 1 or 3 either way, so we don't actually care which way we number it because it will be the same. The double bond starts on the first carbon and on the third carbon. So this is 1,3 butadiene. Okay, we've got a couple more examples to go. Here we have a carbon chain, only 3 carbons long, 1, 2, 3. So you guys know that 3 carbons all in a row is prop. Now that's a double bond, and there's only one double bond, so no need for this di, or if there were three, tri business, just one, so it's just propene. Okay, now the interesting thing about propene is that it will always have to be one propene, because the double bond would either be here or here. So if we number this, it would be 1, 2, 3, or 1, 2, 3. But no matter which way, where the double bond was, it would always be on the first carbon to start. So this is a little redundant, but all propenes are one propene. Okay, one more to go, and then I'm going to write the name a couple times and talk about drawing the molecule, and then we'll be done. Alright, so our next structure presents us with an interesting problem. We can either choose, and we can't really choose at all, but we could choose to not have our double bond in the chain at all. But that is never okay. You must always choose the chain that has the double bond in it, even if the other chain is longer. So if, for example, this chain continued and actually had another carbon there, and this was a 5-carbon chain, and the most you could make was a 4-carbon chain with the double bond, you still must use the double bonded chain. So our chain is actually 1, 2, 3, 4 carbons long. So it is a bute. It's a bute of a chain there. It's got a double bond, nothing else, no two double bonds where I need to make it a diene or a triene. So it is just butene. And we could either number it 1, 2, 3, 4 or 1, 2, 3, 4. The double bond is more important than the branch. So you want the double bond to be the smallest number possible. So that means that our double bond starts on 1. So this is 1 butene. But then we have this little methyl branch. It has just one carbon in it. Circle R. That's our important one. So then we just have this 1 carbon branch. You guys know that 1 carbon is meth. And every branch always ends with YL. So this is a methyl branch. So we'll go ahead and name it as such. This is a methyl branch. And we have to say which carbon it comes off of. Well, if we picked this as our first carbon, this must be our second carbon. The branch comes off of our second carbon. So it is 2-methyl 1-butene. Final answer. Okay. That is just showing you the example of if there is a branch, how you can incorporate it. The practice problems today will not have any branches. They will be straightforward, just single, double, or triple bonded molecules. Alright, now we're going to draw 3 and be done, because these notes are getting a little long. Alright, draw these structures. So, the way I do this is I look at the parent chain, how long it is. Pent. If it's pent, I know there's 5 carbons in a row, so I will draw them. And I will put single bonds. 3, 4, 5. Okay, we know it is a pentyne, so you guys know that "-ine" means there are 3 bonds somewhere. And we're told where? On the second carbon. So here's our first carbon, not there. Here's our second carbon. That's where our triple bond needs to be. Now what you can do is carbon always needs 4 bonds. This carbon only has 1 bond, so it gets 3 H's. This carbon already has 4. 1, 2, 3, 4, so it's good. This carbon already has 4. 1, 2, 3, 4, so it's good. This carbon has 2, so it needs to have an H2. This carbon only has 1, so it needs to have an H3. And that is 2-pentyne. Okay, next one is a butene. Start off the same way. The root but means 4, so we'll go 1, 2, 3, 4. Because it's an ene, I know there's a double bond, and I know that that double bond is on the first carbon. So I draw my double bond on the first carbon. You could just as easily have called this the first carbon, numbering it right to left, and that would have been 100% accurate too. But I'm going to leave mine here. Okay, now we just fill in hydrogens. Carbon always wants 4 bonds. This carbon has 2, so we give it H2. This carbon has 3. I'm going to sneak an H in there for CH, so now it has 4. This carbon has only 2 bonds, 1, 2, so it needs 2 more H's. I'm just going to put them up to the top there. And this carbon has only 1 bond, so it needs 3 H's. Alright, one final example of a diene, and then we will be good. Alright, this last one says it's 3,4 octadiene. Okay, so we've got some things we have to look at. First thing, it's oct, so we know there's going to be 8 in a row. 1, 2, 3, 4, 5, 6, 7, and 8. Alright, then this one's interesting. It says it's an ine, but it says it's a diene. Di means 2, ine means a triple bond. Where are those 2 triple bonds? They're at 3 and 4, carbon 3 and 4. So I look at this and I say that's carbon 1, that's carbon 2, that's carbon 3. That's where my first triple bond is, so I'll put it in. Oh, interestingly enough, this molecule can't actually exist, but we're going to pretend like it does. And carbon 4. This is carbon 4, so I'm going to put a triple bond there. Okay, now all I need to do is fill in the appropriate number of hydrogens. This carbon has only 1 bond, so I'm going to give it H3. This carbon has 2 bonds, so I'm going to give it H2. This carbon has 4 bonds, so it's good. This is why I said the molecule can't exist. This carbon has 6 bonds. That's way too many, but it's fine for right now. This carbon has 4 bonds, so it's good. This carbon has only 2, so we're going to add in H2. This carbon has only 2, 1, 2, so we're going to add in H2. And this carbon only has 1 bond, so we're going to add in H3, because they all want 4. That's 3,4 octadiene. Not a real molecule, but a molecule nonetheless. Alright, good luck. Come in early if you have questions tomorrow.